Here we have a SAT math question. Okay, let's go with the information. Here we have a triangle. In the figure above, AD equals to square root of 3 and CD equals to 1. What is the length of AB? So we have the length of AD, that is square root of 3, and we have the length of CD, that is 1. We have to find the length of this AB. Okay, now let's consider the right triangle ACD over here. In this right triangle ACD, we have right angle at D, and we have the lengths of the two legs CD and AD. Using the lengths of the two legs CD and AD, we'll be able to find the length of the hypotenuse AC. So AC represents hypotenuse because it's opposite to the right angle. So we can use Pythagorean theorem over here. That is AC square. That is a square of the hypotenuse equals to sum of the squares of other two legs, that is CD square positive AD square. Okay, now so AC square equals to the length of CD is given, that's 1. So 1 square positive, the length of AD is square root of 3. So that is square root of 3 the whole square. Then I'm getting AC the whole square equals to 1 square is just 1. So here the square and square root will cancel. I'm just getting 3. Then AC square equals to 4. Okay, now to get up the square, what I have to do is I have to take a square root on both sides. When I do so, the square root and square will cancel. I'm getting AC. So the square root of 4 is just 2. Usually when we take square root on both sides of an equation, for one of the square roots, we consider positive or negative sign. But here we are trying to get the length of the line segment AC. So it cannot be negative. So I don't consider positive or negative sign for one of the square roots over here. So now I got the length of AC, that is 2 over here. Okay, now let's consider the side lengths of the right triangle ACD. So we have 1 and square root of 3 and we have 2. So clearly when I look at the lengths over here, 1, square root of 3 and 2, ACD is a special right triangle. That is, it's a 30, 60, 90 special right triangle. So only in 30, 60, 90 special right triangle. So we'll be having these numbers as side lengths. And here in these 3 sides, the smallest leg is CD. Because comparing these 3 numbers, so 1 is the smallest number. So in this right triangle ACD, the shortest leg is CD. And the angle measure over here, which is opposite to the shortest leg, must be 30 degrees in a special right triangle. So this A must be 30 degrees. And so the next longer leg has to be AD. So because here we'll have 60 degrees and already we know that it's 90. So when I decide this is 30 and since it's 90, then it has to be 60. So that the 3 interior angles will add up to 180. So already we know that among the 3 sides, so 1, 2 and square root of 3, 1 is the smallest number. So this is the shortest leg. So always the smallest angle will be opposite to the shortest leg. So in this special right triangle, 30 degrees is the smallest angle, which is opposite to the shortest leg. Then the next larger angle is 60 degrees. So opposite to that, we have square root of 3. Anyways, I got the value of A over here, that is 30 degree. So when A is 30 degree and this A is also 30 degree, then what is the angle measure over here? That is 60 degree. Okay, now let me consider the right triangle ABD over here. In this right triangle ABD, I know one of the interior angles, that is 60 degrees over here. Already we know the angle measure over here, there is 90 degree. Then what must be the angle measure over here? It has to be 30 degree. So that in this right triangle ABD, the 3 interior angles 30, 60 and 90 will add up to 180. And now this is the leg. I mean AD is the leg which is opposite to the smallest angle, 30 degree. So this is the shortest leg of the triangle. In 30, 60, 90 triangle, usually we assume X as the length of the shortest leg. So the length of AD can be assumed as X. Then the next longer leg is BD. Then the length of the next longer leg will be X times square root of 3. And hypotenuse is the longest side of the right triangle. So in 30, 60, 90 special right triangle, the length of the hypotenuse has to be 2x when we assume this x as the length of the shortest leg, which is opposite to 30 degree. Okay, now once I get the value of x, I'll be able to multiply it by 2 to get the length of AB. So that's the target of the question. But instead of x, already we know the length of AD, that is square root of 3. So for x, we know the value square root of 3. So when I plug in square root of 3 for x over here, then I'm getting 2 times square root of 3. So the length of the line segment AB over here is 2 times square root of 3. We find this 2 times square root of 3 in answer choice C. So the correct answer choice for this question is C, 2 times square root of 3.